Alright, so I'm going to go over number 2 a little bit more. So I ask you to find the integral of log x to the 3 over x. Integral of that. Alright, so what it boils down to is a power rule with a complicated inner function. Alright. Now, I'm going to draw a parallel. So if I asked you to derive x squared plus 4 to the third, well, that would be 2 times x squared plus 4 times 2x to the power of 2 times 2x. Now I'll explain that a little bit more. Basically, we leave the inner argument on the first part, and then we do the power rule. But then we also multiply it by the derivative of the inner function. Okay? So similarly, we can do an integration to show this if we want to go back to this. So here I do d by dx. But here, if I want to show the integral of this, one way that I can do it is to say u the power of 2, and then I can say du, okay? And what that enables us to do is to say, okay, well, I have that power, and then I have a du outside, so I know for a fact that I can reverse in, I can move it back to this form, so it ends up that this is going to be, where this is 3, my apologies, 3 from the power 3 and to the power 2, okay? So now that just means that I can have u to the 3 now, where if I do the integral of this, okay? So I hope that makes a little more sense as far as my thought process goes. So similarly for this, what do we have? Well, we have a log of x to the power of 3, and then we have 1 over x, okay? So this is the same as this form, where I have a u to the third times a du, basically. That's what it is, okay? So if I go from this step to this, well, that's simply like, I'm trying to think of the best way of perhaps explaining it. When I actually go through the integration, we know from the power rule that I have to have a 1/4 in front, log x to the 4. It's basically just making sure that you're keeping track of this. Trying to think if there's a good way for me to explain it using the tools. Yeah, I'm not sure if I have a better explanation. Let me think for a second. So if I take the I'm just gonna workshop this, so forgive me if I just seem like I'm just doodling. So I'm gonna go ahead and erase this part. Okay, so what I'm going to do here is I'm going to say, okay, well, we have some function u, alright, and that's the power of 3, and we have du, okay? Now, we need to take care of that power still, okay? So, I'm going to use the argument w to denote the 3 So here we can say u like God, I'm trying to sorry guys. So if we have something of the form u to the n, and we want to take the derivative, what we get is n minus 1 from the power, right? God dang it. We have n times u to the n minus 1, that's what I wanted, times du, okay? That's what that is, okay? If we take the derivative of u to the n, we get n times u to the n minus 1 from the power rule, and then because of the chain rule, you have to drag the du, which is the derivative of the inner argument, out, okay? So that's my thought, okay? So using this, we can say, okay, we have a u to the 3, but we don't have a 1 over n plus, or we don't have an n plus 1 outside where n plus 1 is 4, so we have to add 1. Yes. So if we consider 3 to be n, in this case, or n minus 1 now, n is actually 4, but since there's no 4 out front, we can assume that there's a 1/4 there instead. And so what that yields us is, well, this equation right here. Hopefully that makes sense. I don't know if I'm very clear about that, but I hope that clears things up.